Voy a hablar en español solo esta primera parte para darles la bienvenida. Yo soy Andrés Herrada, trabajo en la Biomédicas, y para decirles que a gente especialmente de Santiago o de Concepción, de otras partes, o de Uruguay, que tal que igual tiene sus cosas bonitas. Les recomiendo, por ejemplo, ir al centro, donde en la plaza, a una cuadra, hay un museo precioso que es gratis. Está el río Claro, que de claro no tiene mucho, pero igual es un pasatiempo. Hay también, por ejemplo, completos mojados, que suena mal, pero es súper rico. Yo soy de Valparaíso, iba con súper poca fe y súper bien. Es la 6 Oriente, acuérdense, son unos 5 o 6 Oriente, por la Alameda, que es donde hay hartos árboles, y ahí pillan un completo mojado. Suena mal, pero de verdad yo iba con súper poca fe y me encantó. Ahora soy fanático del completo mojado. Ya, eso. Ahora voy a hacer el switch a Spanglish, así que hello everyone, my name is Andrés Herrada. And I'm going to present this title that sounds like weird, but it's actually pretty interesting, I hope. It's called Immunomodulatory Effect of Illness Paraguariensis over immune cell and its impact in inflammatory diseases. So, our lab, and I say our lab because I work with my wife, who is also a very good, great scientist. And I have to say, every time that I present, I have to say that at the beginning. No, it's a joke. And our lab is very focused on lymphatic vasculature. Lymphatic vasculature is is a network that moves lymph, which is the extracellular liquid, back into the circulation. And as you can see, it's composed of a small vessel and large vessels that are involved in maintaining the body fluid homeostasis, lipid transport, and as an immunologist, immune cell trafficking. Okay? So our lab is called Lymphatic Vascularity and Inflammation Lab, has several like grants. We are focused on understand lymphatic defects and neuroinflammation. It have been described that there is lymphatics in the meninges, is a layer that covers the brain, and is involved in neurodegeneration. So we have a model, an animal model who developed an Alzheimer-like disease, and we study what is the role of lymphatic, and this is a fundesit regular from Dr. Escobedo. I have my own fundesit. I'm very interested in understand the role of lymphatics in autoimmune diseases, and we actually are trying to publish some paper about it. This was my fundesit initiation, but it finished it. And when something is finished in Turkey, you have to worry because there is no money, very few collaboration, not too many researchers. So, but fortunately, I got the fundesit regular now, so that's pretty good. Now we have money to continue exploring the role of lymphatics now in lupus, but in other autoimmune diseases. We are also interested in understanding microbiota and the role of microbiota in lymphatic vasculature. And this is a fundesit postdoctoral from a postdoc who is how do you say postnatal? He's in postnatal now. I don't know how to say in English. Maternity leave. Thank you. She's in maternity leave, and we are waiting to return so we can continue evaluating that. And we have also another fundesit postdoc, and we're interested in evaluating the role of one protein which is called neuraminidase 1 in macrophages polarization and its role specifically in multiple sclerosis, an autoimmune disease. So we are a lymphatic vasculature lab. When you're thinking on lymphatics, thinking on us. And we have actually a very nice story that I'm not going to present today because she already saw that presentation, and it was like a little embarrassing to present it twice, the same thing. So I say, okay, I'm going to present something different. But what we actually found is that the lymphatic is a network of capillaries and larger vessels that move the lymph. When there is a damage and the lymph leaks out from the lymphatics, there is it induces like an immunosuppressive stage that promotes macrophage to move into an anti-inflammatory phenotype. And this anti-inflammatory phenotype have huge impact in different inflammatory contexts. For example, we observe that in colitis, when you have the lymphatic damage, it's good because there is a suppression of inflammation, so the animals are pretty good. But in a model of cancer, it's the opposite because you need at the beginning inflammation to attack the tumor, and then you need to resolve the inflammation. And this was published last year Okay, John. Anyway, why I say all this introduction? Because we are a lymphatic vasculature lab, but I'm not going to present anything about lymphatic vasculature. Why? I don't know, because of her. Anyway, so I'm going to present something completely different, and I'm going to start with this slide. This slide is a very old picture of a foreign visitor who visited Chile around 1830s. So he drew, and that, by that time there was no photograph. This is a classical like Chilean society of that time. And look at that. They look pretty different. Yeah, look, look. No, look at that. They are very different to us. As you can see, they were very Catholic. But also, I focus on, look what they are drinking. You see in their hands? Look. They are not drinking tea or coffee. What they are drinking yerba mate. Yerba mate was the most popular beverage in Chile until 1860s. So everybody drinks and they drank. No, they were not drank yerba mate. And so why we are not drinking yerba mate anymore? Most of us. Because by 1870s, there was a huge English influence that they bring, for example, football or soccer, no, depend on, but they bring, we take several culture from England, and of course, with England, they bring the tea. So the reason why you are drinking tea at once and not yerba mate is because English people or English influence. Okay? That's it with history. Now we are going to talk about yerba mate, or it is also called, the name is Ilex paraguariensis. Yerba mate is a subtropical tree with several benefits, and it's grown in Brazil and Uruguay mainly. It is consumed as an infusion, either cold or hot, depend if you are from Uruguay, Chile, Argentina. And as you can see here, you know yerba mate, you immediately think yerba mate, Argentina or Uruguay. But actually in Chile, there are a lot of people who still consuming yerba mate, especially here in the south. So when I arrived to Talca, I say, oh, so what I'm going to study? Okay, let's see the people. People eat completos mojados, and they drink yerba mate, and I say, okay, let's study yerba mate. So in the south of Chile, there are a lot of consumption of yerba mate, and in the countryside. So probably maybe you or your parents or grandparents still consume yerba mate. And there have been described in the last 10 years several beneficial effects of yerba mate. Most in vitro, but still. There is anti-obesity properties, anti-swelling, anti-cancer effect, especially in vitro. This is only in vitro. Antimicrobial effect, neuroprotection, and antioxidant. So, but me as an immunologist, I'm interested in immune response, and this course is inflammation, so I'm also interested in inflammation. So we're wondering, can yerba mate regulate the immune response and inflammation? To understand what is inflammation, I would like to give you a brief summary of what is the immune system. The immune system is composed of two layers. One layer, which is called innate immunity, is composed of tissues and cells that attack any pathogen or tumor cell very quick. It is always patrolling our body, and in a couple of hours is able to clear the infection. However, if there is some problem with the innate immunity, we still have a second layer to protect us, and it's called adaptive immunity. And the adaptive immunity is composed of a very specific cells, which are called B cells and T cells. B cells that produce antibodies, and T cells that orchestrate the immune response. And these take days to develop, right? So if you feel bad, if you feel sick and go to the bed because you feel sick, it's because you are you are increasing the number of T and B cells until they specifically attack the infection and clear the pathogen, right? So, and what is the effect of that? You kill pathogens, tumor cells, etc. I love that etc. is similar to Spanish, right? It's etc. Oh, so nice. Anyway, in a normal situation, what you have is that there is an injury, a pathogen, any kind of problem, the immune system responds, and there is this phase which is called resolution of the infection. The immune response needs to be cleared out, so we return to the homeostasis, right? And in this process, there are two cells that are going to play some roles. One is called anti-inflammatory macrophages, and the other one is called regulatory T cells. And this part is important. You always need to clear out the immune response. Why? Because if the immune response cannot reduce and is still high, it creates what is called chronic inflammation. Chronic inflammation is a stage in which the immune system is constantly activating, producing pro-inflammatory cytokine, inflammation. And what is the problem with that? A lot of problems. For example, it has been involved in promote inflammatory diseases, such as IBD, inflammatory bowel diseases, colitis, or Crohn's diseases. Autoimmune diseases, like lupus, multiple sclerosis, which we study in our lab, rheumatoid arthritis, I don't know, but there is more, is also promoted by chronic inflammation. Neurological diseases such as Parkinson or Alzheimer, it's also triggered by chronic inflammation, and of course cancer. So look at this slide. If you control chronic inflammation, maybe you can control the diseases which are triggered by chronic inflammation. So the question is, can yerba mate regulate inflammation? Answer, no. Thank you very much. No. So imagine you are in Talca, you don't have too much money. What do? You do easy experiment in terms of days and in terms of cost of money. So we decide to evaluate it in this model. Dr. Hermoso already talked about this. IBD, inflammatory bowel disease, you can divide it in two main groups. One is called ulcerative colitis, which is an inflammation in the last part of the colon, and Crohn's disease is where the inflammation is in a spot in entire large intestine. So, and we have in our lab a model in which you can induce colitis in mice by giving DSS that trigger inflammation in the colon, and it's a very good model similar to what is happening in ulcerative colitis, right? So what we did to these mice, we give them by 7 days before start the colitis induction, yerba mate. Obviously they do not drink, because if you put the yerba mate, we give it like by oral gavage in a similar like with tops, I don't know. And for 7 days, and then we induce colitis and continue the treatment with yerba mate or vehicle during the entire experiment. And what we measure? We measure classical parameters of colitis, like weight loss, survival, inflammation, blood in the stool, etc. Okay? So, what we saw. This is the classical weight loss observed in animals. Animals or people who suffer colitis lose weight very rapidly. Yerba mate did not have any effect on the weight loss in our case, which is, I was expecting, because yerba mate is used as an anti-obesity drug, or not compound. But when we observe the animal, they look pretty healthy. As you can see here, these are the vehicle animals, and these are animals treated with yerba mate. And only because they drink yerba mate, they feel pretty nice. You have to touch the other one so they can move, right? So this is huge. I mean, yerba mate do this. And if we observe clinical parameters such as rectal bleeding, you observe that animals receiving vehicle, all the animals suffer rectal bleeding. But the animals receiving yerba mate, 80% of the animals never bleed. So, pretty nice. And together with that, we observed the survival of the animals was huge. Animals receiving vehicle, basically 65% of the animals die, and animals receiving yerba mate, 80% of them survive. And actually, I'm pretty sure that the animals that die, they do not die by colitis. So these results are saying that yerba mate reduce the symptoms and improve survival in this DSS-induced colitis model. Okay, so then as an immunologist, you have to see inflammation, and that's why I was invited to this meeting. Thanks to this slide, because I put inflammation. If not, I'm not invited, and I cannot eat. So, and what we did, we tried to understand the systemic inflammation, and how do you evaluate systemic inflammation? By evaluating pro-inflammatory cytokine in the serum of the animal. And as you can see here, at different days after DSS induction, we observed a reduction of IL-6 production in animals receiving yerba mate compared to the vehicle control. They receive only water. And this result suggests that systemic inflammation is reduced by yerba mate. But what happened in the local inflammation? What happened at colon level? And to do that, to measure local inflammation, we did this that I learned in US. You take the colon from the animals, you take a very small piece, which is called colon explant, and you put it in culture, similar to what you do with cells. And they produce cytokine, ELISA, not that fancy thing that can measure. And evaluating ELISA, what we observe at day 8, we observe a significant reduction in the levels of pro-inflammatory cytokine IL-6 and IL-1 beta in the colon of animals receiving yerba mate, meaning that yerba mate reduces not only systemic but also local inflammation, and that probably is that's why the animals feels better and survive. So next question, why? And I say, okay, wait. And to understand why, you have to think about this picture that I already showed you. In the resolution phase, there are two main cells involved in reduce the inflammation. One are the anti-inflammatory macrophages, and the other one are Tregs. And we focus on anti-inflammatory macrophage because it is pretty well known that they play a key role in controlling colitis. And one of the markers for anti-inflammatory macrophages is CD206. So if you see CD206, you think anti-inflammatory macrophages. Here, these are colon slides from animal receiving vehicle, and we mark for CD2, there's several, F480, CD206, and live one, which is a marker for lymphatics. Remember that we are lymphatic vasculature lab, so we measure lymphatic, but we didn't see too much change, so forget about it. But look to CD206. As you can see here, day 0, 5, or 8, there is not a huge amount of CD206 in the colon of the animal treated with vehicle and induced with colitis. However, the animal receiving yerba mate, even though at the beginning but similar numbers of CD06, this anti-inflammatory macrophage, huge amount of anti-inflammatory macrophages in the colon at day 5 and at day 8 that were significant, meaning probably that these anti-inflammatory macrophages in the colon, they are controlling the inflammation triggered by yerba mate, and for that reason the animals survive better and they don't feel the pain induced by, triggered by colitis. So, I don't remember, one that, can yerba mate promote anti-inflammatory macrophage polarization in homeostasis? Okay. The effect that we observe is because yerba mate or because we induced colitis? You can say, of course, yerba mate, because the other one we induced colitis and still we don't see CD06. But the reviewer say, okay, you have to prove it. And to prove it, remember, with no money, we repeat the experiment. But in this case, we take the animals, we gave them for 7 days yerba mate or water, and then we analyze the number of anti-inflammatory macrophages in different tissues. Which tissues? Spleen and lymph node, because we are immunologists. Well, this is a flow cytometry that I'm going to show you. You have to just focus here. These are the anti-inflammatory macrophages, and these are the pro-inflammatory macrophages. And as you can see here, compared to vehicle, where you have 24% of anti-inflammatory macrophages in the, I don't know where, this should be in, well, spleen and lymph node, I don't remember where. Well, anyway, lymph node, compared to yerba mate, we observed 57% of anti-inflammatory macrophages. And concomitant with that, look at the number of pro-inflammatory macrophages. It moved from 10 to 1. And we actually repeat the experiment and give us a significant difference. These results suggest that yerba mate per se induce the proliferation or the polarization of anti-inflammatory macrophages and maybe induce it like an anti-inflammatory stage, and for that reason it protects us from colitis. Okay? Finally, regarding to this part, yerba mate we give them to the mice, and a lot of variables, you say similar, right? Variable. And so we now take bone marrow and we differentiate into macrophages. The question is, can yerba mate directly promote the polarization of macrophages into an anti-inflammatory stage? Now take out the macrophages and put with yerba mate. And we, again, by flow cytometry, did a lot of stain. Doesn't matter. What it really matters are the results. The answer is no. Yerba mate in vitro is not able, you can see this population, is not able to promote anti-inflammatory macrophages. What suggests this result? This result suggests that what is yerba mate doing is changing something in the body of the mice, and that change promotes the proliferation or the polarization of anti-inflammatory macrophages. It's not a direct effect over the macrophages, it's an indirect effect. Anyway, what about different inflammatory contexts? We are pretty sure that yerba mate works for colitis, but we are not sure in another inflammatory context. And to be sure to be invited to this meeting, I did 2 inflammatory models. See? And what is the next inflammatory model that I studied? Autoimmune disease. Because we already have a lot of experience. We have only been here for 5 years in Talca. We arrived in 2017, but still we did a lot of experience. And we have this model that multiple sclerosis. First, multiple sclerosis is an autoimmune disease. This is a neuron, and this is myelin sheath that allows the nerve impulse to jump and go faster, right? And the other thing that you have to see here is this. This is called blood-brain barrier. There is a barrier that blocks the entrance of immune cells into the CNS, the central nervous system, right? What happened in multiple sclerosis? It has been observed that there is a damage of the BBB, blood-brain barrier, and the entrance of immune cells, especially T cells, and these cells attack the myelin sheath and destroy it. And what is the problem with that? That the transmission is not good, I don't know, it's bad, and it induces different symptoms in different people. It depends on the neuron that is compromised. For example, some people can suffer vision blurry, brain disorders such as depression. Most of them have muscle problems. They cannot control very well their bodies, etc. So we have a model in which we can induce multiple sclerosis into mice, and it takes only 25 days to resolve. So it's very easy and fast. And we induce, basically, we put a mock protein that imitates a protein from the myelin sheath, and we treat it also with pertussis toxin that destroy the BBB, and then you induce the EI, multiple sclerosis. And so we repeat exactly the same experiment. We gave the mice yerba mate or vehicle for 7 days, then we induced multiple sclerosis and continued treatment, and we evaluate AIA progression. How do you evaluate AIA progression? It's very similar to what happened in humans. They begin to have problems with muscle problems, and you can score that. It began from tail to head. A flaccid tail is number 1. They begin to lose power in the legs, etc., and you can score that. Okay, what happened with the result? And what we observed, this is the clinical score that gave us how is the AIA, the multiple sclerosis, progressive. Anyway, you understand me. 100% of here speak Spanish, but anyway, continue in English. As you can see here, compared to the vehicle control, animals receiving yerba mate, first of all, delay the appearance of the symptoms. I was very happy here, not that happy here, but anyway. Not only that, the progression of the disease is lower and is less severe. Less severe. You give them yerba mate, and the symptoms of EIE is less severe. And not only that, if we analyze incidence, all the animals, we induce AIA. We induce that they develop multiple sclerosis. And of course, 100% of the animals receiving vehicle develop EIE. However, 40% of the animals receiving yerba mate never get sick, even though we induce the disease. That means that yerba mate not only reduces EIE symptoms, it also blocks the development of the disease. And if you remember, I said that multiple sclerosis, there is an entrance of cells into the CNS, right? So we want to see if this is happening in an animal. So we take, this is a slide, and we stain it for CD3. CD3 is a marker for T cell. And these are two different slides from an animal treated with vehicle. And as you can see, there is a lot of red dots. Red dots meaning T cells in the brain, meaning damage, neuroinflammation. And what happened with yerba mate? Yerba mate, we see a huge reduction in the number of these infiltrated T cells. And we put a person to quantify, and she quantified not only T cell, but also IVA1, which is a marker for microglia and maybe macrophages, infiltrating macrophages. She just finished it yesterday. She was 3 months counting. No, our lab is not that bad. But as you can see here, neuroinflammation is prevented by yerba mate consumption. And again, why? And if you remember this slide, there is 2 cells, and in EIE, or in multiple sclerosis, it is very well known that Treg play key roles. And Treg express one protein which is called FOXP3, that is a transcriptional factor, so you can identify very easily the Tregs. And what we did, we take mice and give them yerba mate. That's it, for 7 days, similar to what we did before. So in an homeostatic condition, and then we analyze, in this case, Tregs in different organs. And what we observe is that if a mouse, is there any mouse in the audience? No? Okay. But if mice drinking yerba mate for 1 week, there is a huge increase in number of Tregs either in the spleen and lymph node. These results suggest that yerba mate is promoting Treg maybe differentiation. To prove that, we did exactly the same. We take now using FOXP3 GFP mice. That means the FOXP3 is under the promoter of GFP. Yeah? 5 minutes. Okay, it's fine. 3. And we basically sort a conventional T cell, T naive. We want to sort not the Tregs, the T naive T cells that are negative for FOXP3. Why? Because we want to differentiate it in vitro into Tregs in the presence or absence of yerba mate. And what we observe again is that compared to control, in vitro, yerba mate is not able to induce the differentiation of Tregs. In other words, again, yerba mate is doing something in the mice that promote the proliferation of anti-inflammatory macrophages and Tregs, but did not act directly in the cells. We don't know yet what is the mechanism. I hope the reviewer is not going to ask. It's nature. In nature, we send it to nature. I don't think they're going to ask for that. Yeah. So what is the summary? In summary, yerba mate reduces colitis symptoms by promoting anti-inflammatory macrophage polarization, and also yerba mate reduces EIE or multiple sclerosis symptoms by increasing Treg number. And the take-home message that I want you to, when you return to Santiago, Concepcion, Uruguay, or whatever, is that yerba mate seems to work like as an anti-inflammatory nutraceutical by modulating key immune cell type. And why is that important? Oh, wait, it's really important. Why? What is next? What we are doing right now? Well, we actually still don't have money, but we are very interested. If you ask me what molecule from yerba mate is doing the effect, I don't know. I'm an immunologist, not a chemist. So I don't have any idea, and I would really like to collaborate with someone to purify different molecules and see which one is the responsible of the effect. But also, what we want to do is we're going to start a clinical trial, a phase 1 clinical trial with multiple sclerosis patients. We're starting a collaboration with Dr. Lorna Galleguitos from Clínica Alemana, and we are going to give them yerba mate as a supplement to their normal treatment. We are not going to just give them yerba mate, of course. But what I hope is that the yerba mate can improve the symptoms of the patient with multiple sclerosis. And I'm trying to look at doing the same with IBD patients, with colitis or Crohn's diseases. And I don't know any gastroenterologist or MD or anyone who work in that field. It would be really nice to talk with Hermoso. With Hermoso, I mean the professor. And because she has a lot of contact but she's not here. She was in Buenos Aires. Anyway, but that is what I try to do. So when the professor asked what is the contribution that we're trying to do, we really are trying to do a contribution in biomedicine in these patients. So, and of course get funding. We're trying to do get funding like desperate. So as the acknowledgement is to our lab, especially Alexandra, Sofia, Francisca, and Valentina, who do a lot of the work together with me and Dr. Noelia Escobedo, because in Talca you are not only a PI, you are a postdoc, grad student, everything. I have to do experiment and try to write papers, grant, etc. I have a couple of collaborators. I wanna highlight Carolina Prado, who helped us with the sorting of the cell. Until November last year, we didn't have sorting in Talca, but now we have. So we are getting independent. We are regionally independent right now. We can do all the experiments here. When that was all the experiments that we did in Santiago, all the other experiments were done in our lab. And of course, to the funding, Fondesit, my university has supported a lot, and I'm a Pew Fellow. And why I say that, because thanks to Pew, they help us to buy a new flow cytometry. So I have a flow cytometry that there wasn't in the university before, and we use it every day. And finally, I want to say that we have an Instagram, and if you want to follow us, so now you can take your cell phone and follow us. And our goal is to move from 25 to 30 followers this year, so I hope we can afford it. And that's it. Thank you very much. You're welcome.
I have the first question. What is your thinking about this group for
You are asking me what is the compound?
Yeah,
What?
what is the phenomenon called anywhere? Because
I put that it was a projection. No, it's fine. It's fine. We have some idea. Uh-huh.
It's very complicated because one is the molecular
Yeah.
interaction, the other molecular. Another part is what is the mediator and the organic or in the metabolic system.
I was waiting that question. I was waiting. But
And the other question
so many questions. Okay.
what is the strategy for study sector that use the common metabolic
Huh?
is very different the matter. It's a clinical trial and the use for the.
Yeah,
different.
you are right. You are right. Well. First question: what molecule we suspect that is the responsible? We believe it's called. I don't know the name in English. It's called ácido clorogénico, which is I don't know. No, I just read a review about ácido clorogénico, which is in the matin. They have several benefits, so I think it's that. I don't even know about the first question. That is the ácido clorogénico, and that's it. If you continue asking me, I will say I don't know. Second question was, what is that? We believe, and we are going to do some experiment. We believe that yerba mate is changing microbiota. So what we are going to do is microbiota transference. So we are going to give them with yerba mate. We're going to take their microbiota and transfer to animals who doesn't drink mate and induce EIE or colitis and see. I'm pretty sure. Well, when you are sure, it never works. So I'm thinking that probably microbiota is changing in the animal, and the microbiota is promoting anti-inflammatory macrophages and Treg. And the third question was regarding yerba mate. We just buy a regular yerba mate that we found in internet is soluble. You know what I mean? I mean, it's instantaneous. You put it and dilute it. It's not the leaf, because it's easy to give them to the mice, right? But so the easy question, I don't know how we are going to do in the clinical trial. I didn't know that there was a lot of yerba mate species. I will focus in the one that I proved. And yesterday I was talking with some guy from my university, and he has some collaboration with Argentinian guy who produce yerba mate, but different plants, different types. So he said, why don't we try to see which one, and then we sell it as a new product, something like that. And I said, okay, when you say Autónoma pay very low, so it could be good. I mean, I can buy a new t-shirt. Anyway, so that's the question, right? Oh, okay. The what? No, no. Yeah. Again, easy answer, no. Why? Because I'm an immunologist, I'm not an antioxidative guy. Maybe there is a collaboration, could be, it has been already published that yerba mate has some antioxidant effect, so maybe it could be for that reason that it's doing this, but I don't think I'm gonna follow the Ross story, only because we don't have funding to do too much.
Thank you.
You're welcome.
Andrés.
Well, nice presentation. It's nice to see that yerba mate is being studied. My first question is regarding something that you answered, that I think it's important for the studies, is which yerba mate you bring to the animals, because it's an infusion, and the infusion you get to the animals can be different if you use cold water to extract the compounds than cold water.
Yes,
That is the difference, for example, between paraguarians and water, between hot mate and paraguarian. And the extract and the composition of the extract can be different. And mainly the compounds that probably are making your results are polyphenols.
Polyphenols?
Yes, that are being extracted from the yerba mate.
What you say is very interesting. He's saying that depends on the temperature that you create, make the yerba mate is different. What we did to avoid that problem, we prepared the yerba mate at 60 degrees. Why 60? Because there were publications saying that over 60 degrees you can kill the possible molecules that are regulating. I said, okay, stop it, we don't read anything, 60 degrees. So with a thermometer, we put it, and we related with the compound that.
60 degrees is like the temperature that you extract most of the compounds.
Yeah.
And also it prevents some other type of currents that you have.
Yeah, exactly. I think, I don't know, Argentinian guy, they drink very hot. And Uruguay are better.
The temperature is 70 degrees, but it's 60 degrees.
Perfect.
But only they are polyphenols, and that's why if you put only for the extract in the cells, maybe
could be.
I agree with you that maybe there are some changes in the material that would modify the type of polyphenols and the way that the polyphenols are absorbed and the pathways that are being activated in the animals. And one of the things of your video that was interesting is, do the animals move more because they were healthy, or because the yerba mate, which it's like coffee, are the way they now?
Yeah. No, the easy question is they move better, they move more because they feel healthy, because we measured different clinical parameters that I didn't put here, and all the clinical parameters like pain or other things were lower in yerba mate compared to vehicle. So I'm guessing that they feel much better, and for that reason they move similar to a wild-type man that never received ESS.
Nice. And last question is, have you tried to give them yerba mate after the disease started?
No, we haven't, because I want to prove first if we work as a prophylactic. Of course, I would try now if the reviewer asks me, because we are lymphatic vasculature group, no yerba mate group. So if we get funding, of course I would try to do like a therapeutic instead of prophylactic. Yeah, so we haven't.
Vicente, luego Mari y María, y terminamos este nivel, si no vamos a buscar.
let me stop. Yes, that's why we started. Either yerba mate, either multiple sclerosis and colitis it's very low. Somebody says it's increasing, right? It's true, but it's really low compared to the worldwide average and especially the northern, I mean Europe and US. The prevalence in Chile of both colitis and multiple sclerosis is very low. People are wondering why. They call the Andes countries have the lower incidence, one of the lowest incidence of, for example, multiple sclerosis. And Andes countries, they consume yerba mate. So I'm not saying that this is their direct effect, but maybe they have an effect. Yes.
Yeah, well, I was asking about similar questions. So very interesting. And I also have another question, and that is, have you looked at ICCP to issue
Have you looked what?
Yeah, and you analyze
Have you looked what?
Have you looked?
Persona? No. We haven't nothing. We haven't done anything. No, we haven't done anything in humans. Yeah, no money basically. I think that is actually my hypothesis. My hypothesis is yerba mate is changing gut microbiota and I don't know. I would say microbiota instead of microbiome. Maybe microbiome is better. That change promote an anti-inflammatory stage. So for that reason, we're going to do this microbiota transference. So to answer that question. I know they already told me. Could be, yeah.
Just a very quick question. How did you find the doses, and how did you compare the doses that you gave to your mice for what you should give to your clinical study?
Yeah. Short answer, because we are not a yerba mate lab, we read a lot of papers and we base it in the doses that there were more published, you know what I mean? Yeah, it was, so I don't remember actually right now what was the doses. Microgram, 0.025 microgram.
How much should a human drink in order to
It's like, it's a good question, and the good answer is that it's not that much. I mean, because we gave them like a dust, like a pulp, right? So we measure, but it's similar to what is drinking. It's like como un mate cargado. Es como un mate cargado. Sí, once a day. Once a day un mate cargado en la mañana nosotros. Sorry, we gave them around noon or at 10 a.m. noon, same day, so we don't have variation during the day, and that's it. Yeah, that should be our clinical trial.